Thank you. We move on with the first regular speaker of this session, Professor Tornabene.
Yes.
You can start with your presentation, please.
Okay. You see my desktop?
Yes, we see it. Very well.
Okay. So, good afternoon, everybody. I will present an higher order mechanical modeling of laminated and lattice composite shells with a complex material and geometry. This is a work due with my colleague Rossana Dimitri. So, I show you a brief outline. So I will try to speak about composite and laminated shells, and I speak about a numerical method to solve these kind of structures and a numerical implementations. And I present also a strong formulation and weak formulation to treat this kind of structures and some applications. Here you can find the main bibliography, all the results that I will present during this presentation you can find in this book. And due to the fact that I have no more time to present all the aspects of this research, I want to present you the software that I use to obtain this kind of results. So regarding all the theory that I use to obtain my results, you can refer to the presentation that has been uploaded to the site. And then I want to show you the software that I use to obtain these results. So this software is based on differential quadrature, and in particular, this software treats the shell structures. And with this software, that is built-in software using MATLAB, we can consider different kind of theoretical approach to study this kind of structures. And in particular, for example, we can start for the simple first order shear deformation theory. So here you can see, for example, the parameter that you need to study this kind of structure.
Excuse me, Francesco, you are sharing the PowerPoint, not the software.
Yeah. Yes, you do not see the software.
The software, yes, you should share the software.
Only the slide. The slide is about the software, but I don't know if you are showing.
But you see the software. No, but because the software is important, because I want to show you the way I used to obtain this kind of.
Okay, I think that you have to share the entire screen if you want to.
Okay. You do not see the screen. I understand.
Only the PowerPoint. Only the PowerPoint we see.
You see only the PowerPoint now.
Yes.
Okay. No, but I want to show this screen. Okay. Now you see the software.
Yes.
The screen. Okay.
Yes.
Excuse me, because I don't see that I share only the PowerPoint. Excuse me.
And we see also your beautiful desktop.
Lord of the Shells.
Okay. And in this kind of software, I want to show you the way of treat this kind of models and the simple way to consider higher order mechanical model to treat the shell structures. So, for example, we can consider first order shear deformation theory. So it's a simple theory that you well known. And then you can consider all the other theory, for example, a simple AD zeta 4. In particular, in this theory, we can consider 18 parameters. And for example, the Murakami function that allow us to consider the zigzag effect. So you can choose also the shear function. So for example, for each column of this model, you can consider different kind of theoretical thickness function. For example, Lévi-Stein-Touretière-Ferreira sinusoidal function, and so other. So you can change the theory using different kind of theory for each degrees of freedom you want to consider and use. You can skip also from the equivalent single layer to the layer-wise approach by using this simple box. And then also for this kind of approach, you can consider, for example, many degrees of freedom, in particular higher order theory, also for the layer-wise approach. And you can consider also different kind of formulation. So you can solve the equation of motion, for example, for this kind of structure using a strong formulation or a weak formulation. So it depends on the way you want to solve this kind of equation, or using differential quadrature method, or using a general integral quadrature method. So you can skip through these two formulation by using this this button. And then when you have considered the theory, you can skip to the material. So in the material, you can, for example, consider 3-layered structures, in particular 3 layers, in this case orthotropic layers. And then, for example, using this software, you can consider also the fiber reinforcers laminates with the oriented fiber along the shells. And this is important because when you evaluate the stiffness of the that you use in the equation, you have to evaluate point by point. So the mechanical properties of the shells varying along the surface of the shells. And so you can do this choice by varying, for example, the parameter you use to obtain this kind of trace of the oriented fiber. For example, that one. Okay, this is a representation of the curvilinear fiber along the curvilinear lines of the shells. So this is for an example that you can solve with this software. Okay, when you have defined the material, you can use you can define the geometry. Okay, for example, a more simple geometry that you can study, for example, a surface of revolution, in particular, for example, a catenary, a shell of revolution using a catenary meridian, and we can obtain this kind of structures, okay? And in this part of the software, you can introduce the geometric parameter that allow you to discretize the geometry, not only in the bidimensional or two-dimensional direction, so in the shell direction, but also in the normal direction. So you can see, for example, the complete 3D shell structures. So in this case, I increase the thickness, and you can see, for example, that we have 3 kind of layer in this kind of shells. But when you use, for example,
Francesco, sorry, I have to stop you. Sorry, because we have to respect the time. It's very impressive, really. Very fascinating.
Yes, I skip directly to the results, okay? Because it's important to understand the result that we can obtain, okay? And for example, I already ran some of the result that we can see. For example, in this case, I study a 3-layered shells, and in particular, this is elliptical shape shells, and I cut this shell using a circle in the curvilinear shells, bidimensional shells. So, for example, I show you the mold shapes in this case. So with this approach, I can study very interesting and arbitrary shaped shells, and then I can obtain results using higher order formulation, using different kind of material along the shell surface. And this is important because it's not easy to consider that the material varying along the surface because we have to consider also not only the variation of the material point by point, but also the variation of the derivative of this material point by point. So this is an important feature that with this software it is possible to consider. Thank you very much. All the things that you want to learn about the theory, about the material, about the result, you can refer to the material I upload to the site online.
Okay.
Thank you very much.
Thank you so much, Francesco. Sorry that I tried to stop you, but it's the time that give me.
Yes. Don't worry.
Only a curiosity if there are not questions, and I ask to answer very fast. Is it possible
Yes.
to model also a pierced vault or pierced shell on the software that you made? Pierced vault, I mean
I don't.
with hole with different holes in the surface.
Yes. Okay. Yes. Okay. I have a slide, for example. Yes, this is a feature because I want to implement. So at the moment, I cannot consider in this software vault or shells with the hole and discontinuities. But in the future, I want to expand the software in order to treat these cases, because as you see in this slide, it is possible to consider, and it's only the step that it's important to implement is the assembly of each part of the shells, so each element. But it is completely possible, because if I can treat an arbitrary shells, I can also consider the combination, and I can consider this kind of structure by implementing the condition between each elements.
Okay. Thank you so much.